Very good evening to all of you. I don't know what's the problem that now it's okay, no? That shall we start now? You are ready?
Okay, sir.
Uh, I already sent the link, but anyway, that maybe technical issue. Now we can go to that our topic network model, and that we talk about the techniques. Last time I explained how to draw the network diagram. Everybody know, and also we talk about the techniques under that CPA method, critical path method. We did three examples according to my memory. Everybody should know that how to uh, draw the diagram, how to identify the critical path. There are two methods I explained. One is the longest path method, and second one is that we call earliest start in time and latest completion time method. I think we did that examples already. Third one also we completed. I'm correct? Now today we should start from the third method. Please let me know. Last time we completed the CPM third example, no?
Yes, sir.
Okay, right. Now today I'm going to explain the PERT method. PERT means project evaluation and review technique. Project evaluation and review technique. You know that we are living the dynamic environment. Environment condition change over the time. The good example, the last 2, 3 days, heavy raining everywhere in the country. Then we didn't know early, very early, we don't know that. But anyway, unexpectedly, there are so many things happen. Then if that type of situations highly affect to the completion of the project. Unexpectedly, that have some environment changes is affect to sometime reduce the duration, sometime it's affect to increase the duration. I mean that we require more time to complete the project because of the last 2, 3 days raining is affect to the especially for the construction project to delay. Or because of the environment changes mean not bad weather condition every time. Sometimes we can see the good weather condition is affect to complete the entire project within short time period. And also that because of the new technology identification is affect to complete early. Identify the new material is affect to complete early. Likewise, there are so many changes. But under the CPM method, we didn't consider these changes. The project manager is going to calculate the time required for the each activity based on his experience. That particular time period somewhat may be correct, sometime is not correct. Most of the time is not correct because it's calculated based on the particular the manager experience. But assume after we calculate the time for the each activity, we can see some changes. Because of the changes, we can't complete the project based on the scheduled time period. Therefore, under the PERT method, we consider these particular changes and we try to calculate the estimate for the each activity duration, considering that three time estimate. The time estimate for the CPM means critical path are the deterministic, while those for PERT are probabilistic. In PERT, each activity has the following three time estimate. We call that optimistic time estimate under best of condition, pessimistic time estimate under the worst of condition, and most likely time estimate under the normal condition. Normally, we use a simple A for the optimistic time, simple B for the pessimistic time, simple M for the most likely time. The optimistic is a good time, right? Like previous couple of weeks that our cricket team, they won the series, they have a good time period, right? That's equal to optimistic. Sometime that the previous World Cup, our team, they lost. There is a pessimistic time period for our team because time period also somewhat affect to that one, right? Sometimes good batsmen, but they can't get the marks. The pessimistic time period. Sometimes we are living the most likely estimate under the normal conditions. Likewise, here we are going to calculate the each activity duration considering three time estimate, three time estimate. Then considering this three time estimate, we can calculate the expected time for each activity, right? Optimistic, pessimistic, and most likely based on that, we are going to calculate the expected time. We can use the formula. The expected time equals simple A plus 4M plus B divided by 6. Then we can identify the expected time for each activity. Now, under the PERT method, you have additional work. The CPM method, normally question given the each activity time period. According to this example, you can say A2, B3 likewise. But the PERT method, you can get the time for the each activity 3 time estimate. Simple A value, simple B value, and M value. Based on that all, we should calculate the expected time. How to calculate? Simple A plus 4M. 4 is the constant. Multiply by the most likely time and plus B, pessimistic time, and divide by 6, you can get the expected time. Under the PERT method, we have possibilities to calculate the probability value. The particular project we can complete within this particular time period. If you want to identify the probability value, we should calculate the variations. How to calculate the variation? Simple B minus A divided by 6 squared. We use that formula to calculate the variation. Simple B minus A divided by 6. Get the square, then you can calculate the variation. Right? Then after you calculate the variation, we need to calculate the standard deviations also, because without we can't identify the probability value. How we are going to calculate the standard deviation? Square root of the variation. The square root of the variation. Right? Likewise, we need to do the calculation. I'll take the example and explain step by step how to consider that PERT method. Okay, consider the following project activities, immediate procedures, and time estimate. Is given the activity A, B, C, D until G. The immediate procedure is given. And also given the 3 time estimate. Now you can see the difference between the CPM method and PERT method. CPM deterministic and PERT method probabilistic. You can see the given information is the difference. CPM method given one column for the each activity duration, but under the PERT method is given the 3 time estimate. Right. Then first question asks, determine the expected completion time and variation for the project. Now, I would like to explain how to calculate the expected time first. Then after that, I am going to explain how to calculate the variation. That's the most important very first time. After that, we should draw the diagram. We need to consider as a duration for each activity expected time. Then using the expected time, we can identify the critical path. Under PERT method also, we are going to identify the critical path. This represents the entire project completion time. Then after that, we can go to the probability. So the second question asks, what is the probability that the project will be completed within 20 days and 25 days? Then after you identify the critical path, we have possible to calculate the probability value using that formula. Then we should calculate the variations as well as a standard deviation. I think much better we can go step by step. First, I explain how to calculate the expected time. I'll share that whiteboard. Then Please let me know that if you can see the whiteboard. Then if you can't see that, please let me know. I think if you can see this, don't worry. Right. Now I share the whiteboard. Then now I would like to write down that formula for the expected time. Expected time equal simple A plus 4 is the constant value, 4m, m is most likely, plus simple B divided by 6. Divided by 6. You can, if you simplify this one, you can calculate the expected time. I'll explain the activity A. Simple A optimistic time 1. Simple B pessimistic time 5. Most likely time is 3. Okay, based on that 1, 3, 5, we can calculate the expected time activity A. Expected time, just I like to take the activity A in bracket. Now we can make the answer. Simple A is 1 plus simple B is 3 into 4. Oh, I think other way around much better. 4 into 3. 4 is the constant into 3. Simple B is 3. Sorry, M is 3 plus simple B is 5. Then divided by 6. If you want that, you can just write the middle in bracket, inside the bracket. 4 into 3. Then much better likewise. Then we can simplify. Then we can identify expected time. First, you can simplify the bracket. 4 into 3 is 12 plus 5, 17 plus 1, 18. The 18 divided by 6, answer is 3. Activity A, expected time is 3. If you understood, then you can go to the rest of the activities and do the calculation yourself. I will share the question again. Better to calculate all the, before that I'll explain how to do the variations also. Then easy to, you can go to both. Variation we are going to calculate. Simple B minus A. Simple B minus A. Right? Divided by 6 and get the square. You can put the bracket likewise and get this squared. That's the way we are going to calculate the variation. If you want to calculate the variation activity A, we can see that simple B value is 5, question given, minus simple A 1 divided by 6 divided by 6, get the squared. I think you should use a calculator for this calculation. Just I calculate only for the activity A, both expected time as well as variation. I think you can take few minutes and go through the rest of the activities, calculate all the activities, expected time and variation. I'll share the question again. Start now, because everybody should know how to do this calculation. Okay, again, you can see the given information. Better do yourself. Don't believe my given answers. You can go yourself and after complete, let me know. Did you complete the answer? Okay, I got a message that complete. Please go to that my next slide, then you can see the answers. A, B, C, D, the expected time. And variations, there's 2 decimal enough. No need to get a 4 decimal. Okay, now next step, you need to draw the network diagram and just write down the as a duration of the each activity expected time and try to find the critical path. Let me know the critical path. Draw the diagram first. Consider the expected time as the duration of each activity and try to find the critical path. Now the student said not still not complete, but now you can see the answer also there. But you know the way how to get it. That is okay, right? I think before draw the network diagram, everybody should know that expected time for the all the activities. If you don't have the question, please use this one and draw the diagram. And you can write down the duration as expected time. Variations not necessary. I will explain later how can use the variations. Actually, we use the variations to calculate the probability value. Okay, now I'll explain the answer. Uh, Actually, I earlier explained how to calculate the expected time using the formula that you should remember the formula, but no need to write down one by one. Let's see how we can do the calculation. Go to the activity A. You can see here the simple A1, simple B is 5, simple M 3. This 3 multiplied by 4 is 12, plus 5 plus 1, altogether 18, divided by 6. A answer is 3. B, 4 into 4, 16, plus 5 plus 3 is 8. 24 divided by 6 is 4. 5 into 4 is 20, plus 6 4 is 10, 30. Divided by 6 is 5. The likewise D, 5 into 4, 20, plus 3 plus 7, 10. 30 divided by 6, 5. Expected time is 5. Likewise, you can just do the calculation. 6 into 4, 24, plus 5, 29, plus 13. 29, 39 plus 3 is 42, divided by 6 is 7. Then F, 7 into 4, 28 plus 10, 38 plus 4, 42, again divided by 6 is 7. Likewise, you can apply shortcut method. No need to write one by one, just get the value, but better to calculate the correct value, right? The middle value 8 should be multiplied by 4 is 32, plus 10, 42 plus 6, 48, divided by 6 is 8. Likewise, you can calculate the expected time for each activity. But I am sure that you can do the calculation for the variations likewise, because we should get the squared. Therefore, we need to use the calculator. Right? Now I'll explain how to do the network diagram. This is very simple example here. Start from the activity event number 1. Then we can do likewise the network diagram. I calculate the early start in time, latest completion time based on the expected time. You can see start from 0 plus 3, but you can't write the 3 because of why the dummy. Highest value is 4. The third event. Second event should be the 4. Likewise, you can see now the entire project completion time is 23. Please let me know, did you complete up to that level? If you are not complete, better complete up to that level and let me know. Then after that, I'll explain rest of the part. Okay, I got it message. Right now, you can find the critical path. You know that I already identified the green color line is a critical path. Earliest start in time value is equal to latest completion time. Event number 1, both values are 0. Event number 2, 4. Event number 3 not equal. The fourth one equal, fifth one equal. sixth one equal. That's the reason our critical path via B, D, E, F. Right? Now, after you identify the critical path, you have possibilities to go to the second question. Where the question asks, let's go to that. The question asks, what is the probability that the project will be completed within 20 days and 25 days? Actually, two questions. One is that within 20 days, one is within the 25 days. First, I would like to explain how to calculate the probability within 20 days. Within 20 days. If you want to calculate the probability, remember we need to calculate the variations as well as the standard deviation. Early, the same question I asked to calculate the variation, all the activity. Because at very first time, you need to get some experience. Actually, if you are going to identify the probability value, remember, or you can write down somewhere, we need to calculate the variation only for the critical activities. Only for the critical activities. Not necessary to calculate all the activity variable. Not necessary to calculate the all the activity variable. We should calculate only critical activities. B, D, E, F. Then you need to add the critical activity variation and get the total variation. Now you can add B variation plus D plus E and plus F. If you go to the previous slide, you can see the B, D, E, F. You can get the variation values. I'll explain. Here, B 1.1, sorry, 0.11, 0.11 plus, we should know that the critical path, B, D, E, F, no? B already got it the 0.11, D 0.44 plus 0.44 plus E 1.7 plus F1. Altogether 3.33 maybe. Did you get the answer? You understand what I mean? After the network diagram, you should find the critical path. Then you can find the entire project completion time is 23 days. Then after that, you should do the calculation total variation. Remember, if you are going to do the calculation, the total variation only required for the critical path activities. You can write down somewhere is very important because sometimes you are going to calculate all the activity variation. But for identify the probability, we require only the critical path. Right? Then here you can see the critical path B, D, E, F. Expected completion time or the entire project completion time 23 days. Project variation 3.32 or the 33. If you want to identify the probability, now we should identify the standard deviation. Now you can calculate standard deviation. How to calculate the standard deviation? The square root of the variation. You can take the square root. 3.32, get the square root. That's we call the standard deviation. The total variation, considering that figure, get the square root. We call this is a standard deviation. Then after that, we are going to use a normal distribution. I'll share the whiteboard to explain. You should draw the normal distribution curve. We need to draw the normal distribution curve. Then in the middle, you can say is a middle value, right? Somewhat my one is not the correct format. I will just change the middle. Much better consider here. We call that the expected completion time. Then we can say the 23. The question asks to calculate the probability within 25 days and 20 days. First, I'd like to calculate within 25 days. The 25 after the 23, right? Then we should identify the probability within 25 days. Normally, according to normal distribution from here to here, the value is 0.5. If the question asks to calculate the probability within 25 days, so we are going to do the calculation. Probability equal, first get the 25, then subtract 23, then divided by standard deviation. Divided by standard deviation. Yes, I put the SD, standard deviation. Let me know the standard deviation 3.32033. Get the square root. What's the figure? Please give me answer. The probability we are going to calculate, 25 minus 23. Let me know the standard deviation value. 3.33 divided by, yeah, I got it answer 1.82. 1.82. Okay, if you want to find the probability, we should use the normal distribution. There are two types of normal distribution Z table you can identify. If you go to the internet, you can search Z table. Here, this is a table we call the cumulative Z table. Right? There are two types of Z table. One is a cumulative, one is a non-cumulative. Why I said the cumulative, we are going to identify this space value, the more than the 0.5. We need to find the within 25 days. We already know from a starting point to middle, I mean the within 23 days, 0.5. But we don't know in between 23 to 25 is a table value, right? Then we can do the calculation. We should use this table to find that total value. Therefore, you need to simplify these figures. 25 minus 23 divided by 1.82, and let me know that answer. Simplify value. 25 minus 23 divided by 1.82. What's the value? 1.09. That's correct. 1.09. Now, after you get this figure, you should check this value from the Z table. You can check this value from the Z table. I explain how to do that. Normally, there are two types of Z table. One is cumulative. The cumulative table given the figures including this 0.5. Right? Including this 0.5. But if you are going to use the non-cumulative Z table, it look like the normal distribution curve. It's non-cumulative. Here the middle value. We call that is entire project completion time 23 days. Question asked to identify within 25 days. Then non-cumulative Z table is colored this area only. Why the top of the table mentioned about non-cumulative Z table. Sometime not mentioned is in this words, they shaded that area only without this 0.5. Without this 0.5. Previous one, cumulative one, you can see, including the 0.5, the figure we can get it straightforward. But here the 0.5, without that, we can get the answer from the Z table. Now we should check the Z table, which value? We should check 1.09. We should check the 1.09. Okay, I will share now Z table. I would like to share that cumulative table is mentioned and also shaded the including 0.5 as well. Let's go to that. Set table I will share now. Now you can see the set table. This table in top of this, you can see the table cumulative normal distribution is mentioned about the cumulative. But sometime not mentioned in using the words, but is given the shaded normal distribution curve likewise. Is shaded more than the 0.5. Right? More than the 0.5. It means the cumulative. Now we should find the value for the 1.09. We need to get the value from the 1.09 using the Z table. First, you need to consider the Z column. You can see this table, Z column. What are the figures? First column, right? 0.0, 0.1, 0.2, 0.3 likewise. Top of the table have some other figures as well. Top of the table, you can see several columns and heading 0.00, 0.01, 0.02 likewise. Now we need to find the value 1.09. Using the Z column, get the maximum value. Now we need to find the 1.09. If you consider the Z table, you can find 1.0 maximum. Because we require the 1.09. Don't take 1.9, right? Because we need to get the Z table 1.09. Then you can get from the first Z column 1.0. Now required another 0.09. Go to the top of the columns. You can see the last column 0.09. 1.0.09. You can just go to that particular row and you can the particular column, the intercepting point, you can see the value 0.8621. 0.8621. Right? That's the value we need to get it as a solution answer. You understood? Just go to the Z column, select 1.0, the maximum value from the Z column. We require another 0.09. Then you can go to the last column, the intercepting point of the 1.0 and 0.09, the value is represent 0.8621. Normally, if you are going to use the cumulative Z table, straightforward, you can get the probability value. Straightforward, you can get the probability value. The probability value is, you can say, 0.8621. 0.8621. It's mean 86%. How we are going to define? We can complete the entire project within 25 days. The question asks within 25 days. The probability value is 86.21%. 86.21%. Right? Assume we are going to use the non-cumulative table. You can go to the internet and download. Right? Non-cumulative table, you already know is figures given without 0.5. If you are going to check the 1.09, you can just select the Z column 1.0 and the last top of the column 0.09. Then instead of the 8621, 0.8621, you can see under the non-cumulative table. Can you predict yourself? You can see the non-cumulative table. What's the value? Without 0.5, 0.5. If you use the non-cumulative table, you can see the value the same place. Let me know. What is the value you can see? Yes. I got it to answer that yes, 0.3621. Instead of the 8621, you can get the 0.3621. If you use an uncumulative table, you can't say the probability 36.21 is wrong because we should add the 0.5. If you use an uncumulative table, remember you need to add the 0.5, then 0.5 plus 0.3621, you can get the same answer, 86%. The particular project we can complete within 25 days. The probability value is 86%. Right? Because expected time 23, then 25 question asked, then we have higher probability. Right? That's the way we are going to use the set table to say the probability value. Okay, let's go to the second part of the question. Do you have any clarifications? Do you have any clarifications? Now I'd like to explain the second part. I mean that if the question asks to identify the probability within 20 days, then much better we can use again whiteboard to explain within 20 days. If the question asks within 20 days, okay, one of the students asked to Udani asked that explain again how to use this set table. Non-cumulative table again. Okay, non-cumulative table means here you can see now I just draw the normal distribution curve here, right? The non-cumulative table, the figures is given without 0.5. You can see the top of the normal distribution curve, we color that whole area, including 0.5 plus with in between the 23 and 25. But the non-cumulative table, the shaded eye, the user lines only for within 23 and 25. This means 0.5 not included. The table also given the same figure, right? Without 0.5. Then if you are going to I have now the cumulative table. If you are going to this particular table, first you can select the Z column 1.0, the maximum value, because we need to check the 1.09. The 0.9 you can get from the top of the columns. Last column you can see 0.09. The intercepting point of the 1.0 and the 0.09, this table is given the 0.8621 because this is a cumulative table. But if you use a non-cumulative table, here the figure is given, I am sure, 0.3621 without 0.5. Then when you are going to keep the answer, right? Cumulative table is straightforward. You can write down the answer is 86% probability. If you use a non-cumulative table, you can keep the answer 0.3621 plus 0.5. You should add the 0.5. Then you can keep the answer again 86% probability. Now you understood? Better download.
Yes, sir. Good, sir.
Okay, better download that from the internet, both table, because why I explained that sometime you can get the cumulative table, sometime you can get the non-cumulative table. Then you should know how to use the both.
Okay, sir.
Okay, right. Now, let's go do the calculation within 20 days. Within 20 days. If you are going to calculate the within 20 days, again, we can draw the normal distribution curve within 20 days. Okay, in the middle, we know that expected completion time, we require 23 days. But now question asks, identify the probability within 20 days. 20 is before the 23. Here the 20. Right? Here the 20. Now we should identify within 20 days. This area. But the cumulative table given, including the 0.5 as well. Okay, don't worry about. The question asks within 20 days. How we are going to calculate the probability? You can write down normal formula, probability equal. Remember, first we should write down the within number of days. The question asks within 20 days. Previous also we calculate. Likewise, question asks within 25 days. We took the first 25. Then subtract the expected completion time 23. Then divided by standard deviation 1.82. Right? Just simplify and let me know the figure. You should simplify 20 minus 23 divided by 1.82. Let me know the answer. Minus 1.64. That's fine, correct. Minus 1.64. Now you know that we should check this value from the Z table. When I'm going to check this value from the Z table, temporarily you can forget the minus. Just get the 1.64 and use the Z table to get the value. You understood? The previous within 25 days, we got the plus value. Now we got the minus 1.61. Then when I'm going to check the value from the Z table, forget the minus, right? Temporary, you can assume we don't have minus. Then check 1.64. 1.64. Okay, I got it answer 0.9495. Anyway, I'll share the Z table again. Some students still sometimes have problem. They should know how to get the 1.64 using the Z table. Go to the Z column. Maximum you can get the 1.6. I required another 0.04. The 0.04 you can see this column. The intercepting point value is 0.9495. But if you are going to write down the answer 94%, that's wrong. Because after you get this figure 0.9495, you should think about that the real value is, we got it, minus value. Therefore, if you are going to say the probability is 0.94 that's wrong, because how can complete the project within 20 days? According to the expected completion time, we require the 23 days. Question asks within 20 days probability. Therefore, probability is very less, right? The previous, if you think practically. Then how to identify the correct probability value? Because of the minus, right? We need to use we use a cumulative Z table, then it's already include the 0.5. Then how we are going to identify the correct probability value? 1 minus probability equal 1 minus 0.9495. 1 minus. Why we took then 1? Because the cumulative table already include the 0.5. We need to, therefore, we should subtract from the 1. You can get the answer as a percentage. I'll let get the answer straightforward 5.05. I'm sure. Percentage. That's the probability. Right? If you use a non-cumulative table, how can get the probability value? Non-cumulative table, we should subtract from the 0.5 only. 0.5 only. Subtract. What's the figure? Non-cumulative mean 0.4495. Then if you subtract that amount, you can get the same probability value. Same probability value. Here I use the cumulative and non-cumulative table to get these figures. The first one, cumulative. Second one, non-cumulative. Right? Now we complete. Any questions, clarifications? Deshani? Do you have any questions? Okay. The Dulanjana, no? Okay. Said that clear. Very good. Now, go to my answer. Now you can see that first I do the calculation for the within 20 days. But purposely start from the 25 days, because very first time I am going to explain the minus values, not good. That's the reason I skip and explain the within 25 days. But in here answer, you can see first I make the within 20 days. 20 minus 23 divided by 1.8203. I got the minus 1.64. Actually, here you can see I use that non-cumulative table. That's the reason I got it the 0.4495. If you use a non-cumulative table without the 0.5, no, then subtract from the 0.5. Right? Subtract from the 0.5, then you can get the answer, probability 5.05. Then within the 25 days, 25 minus 23 divided by 1.83, then you can get the value 1.09 from the set table. I use again non-cumulative table. That's the reason I got it the 0.3621. When you're going to keep the answer at the 0.5, then you can get the 86.21. Any questions? Any clarifications? Now we complete the third method. Any example now, same procedure you can apply. Here I purposely asked two questions within 25 days, within 20 days, likewise. Given the any number of days and ask the probability, you have possible to calculate. Any questions? Everybody understood? Now already complete. First example under the PERT method. When I'm going to apply the PERT method, you have additional tasks. You need to calculate first expected time for all the activities. Then try to find the critical path, identify the entire project completion time. Then after that, if you're going to calculate the probability, you need to identify the variations only for the critical activities. If the question asks to calculate all the activities, you should do the calculation. But if the question asks only the probability value, remember you need to calculate only the critical activities variation, get the total, get the square root. We call the standard deviation. Using the standard deviation, we can calculate the probability value. Now, you okay now? Anybody have questions, clarifications? Udani.
Clear, sir.
Okay, right. If others have any problem, then you can ask from the Udani. She know how to make the answer. Okay, let's go to that second example. Now again, you have the activity immediate procedure and the 3-time estimate, optimistic, most likely, pessimistic. Let's go to the questions. Draw the project network, calculate the expected time for each activity. What are the non-critical activities? Identify the critical path. Identify the entire project completion time. Can activity D and F be delayed without delaying the entire project? Last question, determine the probability of the completion of the project in 28 days. Within 28 days. Okay, I think before explaining, you should do the answer, right? Draw the diagram, calculate the expected time, use the expected time as a duration of the activity, identify the critical path, identify the entire project completion time, and try to calculate the probability. I'll explain. Before that, better to do yourself. If you have difficulties, you can ask questions. Now start. Did you complete the answer? Okay, you can check that expected time. I'm going to explain now. Activity A, 3 into 4, 12, plus both sides 6, 18, divided by 3, divided by 6, answer is 3. Activity B, 4 into 4, 16, plus 8, 24, divided by 6, 4. C, 5 into 4, 20, plus 10, 30, divided by 6, 5. D, 2 into 4, 8, plus 4, 12, divided by 6, 2. E, 0.5 into 4, it should be 2, plus 3 and 1, 6 divided by 6, answer is 1. F, 4 into 4, 16, plus 8, 24, divided by 6, value is 4. G, 6 into 4, 24, plus 7, 31, plus 5, 36, divided by 6, answer is 6. H, 3 into 4, 12, plus 6, 18, divided by 6, answer is 3. 2 into 4, 8, plus 4, 12, divided by 6, answer is 2 for the H, I. J, 3 into 4, 12, plus 6, 18, divided by 6 is 3. K, 2 into 4, 8, plus 4, 12, divided by 6, 2. L, 5 into 4, 20, plus 10, 30, divided by 6, 5. Likewise, is to do the calculation, and when you're going to do the calculation for the variation, better to consider only critical activities. Now you can draw the network diagram. I'll explain how to do that one. First, you can take the event. You can see event number 1. Then do the first activity is A without complete anything. A none. Just name activity. Next, for the B, we should complete A. For the C, we should complete A. After complete A, we can start BC both. Then should be the second event. Then you can name B and C. Then after that, for the D, we should complete B. For the E, we should complete B. After complete B, we can start after the third event, the two activities D and E both. The next, for the F, we should complete C. After complete C, we can start F. Next, for the G, we should complete D. This should be the event number. Here the 4 and 5th one. Now after complete D, we can start G. Not start date. Then you can draw the G. The next one, for the H, we should complete EF. H we need to complete. EF. From the event number 6, we can start H. Next one, for the I, we need to complete H only. For the J also, we should complete H only. Given number 7, the two activities, you can start from that point. I and J. For the K, we should complete G, I both. We should complete G, I both. Given number 8, gonna start K. Next, for the L, we should complete JK. After complete J and K both, we can start L. Ninth event. We can complete the entire project after 10th event. Okay, now let's say we should do the diagram. Then you can just write down the expected time. I only calculate and just try to find the critical path. If you want to make the answer, let me know the A, B, C, D, the expected time values. If you want to complete, let me know the expected time for each activity. If you can make the answers, no problem, that you can do that yourself also. I got the values A3, then B4. If you have any problems, let me know that if the answer is wrong. C5, I earlier explained that how do the calculation is not takes time, it's so easy. D2, E1, F4, D6, H3, I2, J3, A2, L5. Okay, now you can calculate the earliest starting time and latest completion time. Start from the event number 1, 0. Plus 3, 3 plus 4, third event 7. 3 plus 5, fourth event 8. Then sixth event 2 paths, 7 plus 1, 8. 8 plus 4, 12. 12 plus 3, 15. Then 7 plus 50 went via the D, 9. 9 plus 6, 15. Via the I, 17 is the highest. 17 plus 2, 19, 19. 15 plus 3 is 18. 19 is the highest. Nineteen plus 5, 24. We can write down 24 as a same latest completion time. Then subtract the duration, 24 minus 5, 19, minus 2, 17, minus 2, 15, 19 minus 3, 16. The least value is 15. 15 minus 3, 12. 17 minus 6, 11, fifth event. 11 minus 2, 9. 12 minus 1 is 11. 11 minus 2 is 9 is the least value via the D for the third event. Then 12 minus 4, 8 for the fourth event, just only one path. Then for the second event, 2 paths via the B and C, backward 9 minus 4, 5. 8 minus 5, 3 is the least value. 3 minus 3, 0. Now you can see the critical path. A critical then C critical, S critical, H critical, I critical, then K critical, L critical. I write down the critical parties. A, C, F, H, I, K, L. Entire project completion time is 24. Just check month or days, right? Let's see the question given. Days. Now we are going to calculate. Okay, let's go to the step by step. First question. Draw the project network and calculate the expected time for each activity to be completed. What are the non-critical activities? Part B answer we can make now. Non-critical activities. You can say that activity B, D, E, G, and J. These are the non-critical. The next question asks, identify entire project completion time. We identify 24 days. Then can activity D and F be delayed without delaying the entire project? D and F. How are you going to make the answer D and F? Just check the D, F, critical or non-critical. You can see the D non-critical. D non-critical. Then you can say activity D can be delayed because of non-critical. Then activity F cannot delay because of critical. That's why you should make the answer this question. Then after that, question asks to determine the probability of completing the project in 28 days. In 28 days. When I'm going to make the answer this question, better draw the normal distribution curve. Then you can mention that expected completion time is 24 days. 24 days. Question asks, complete within 28 days. Within 28 days. The 28 this side. You can use any table, either cumulative or non-cumulative. You need to find the area this area, you can find the value, the shaded area. Then how we are going to do the calculation? Probability equal 28 first minus 24 divided by standard deviation. But still not calculate the standard deviation. When you're going to do the calculation of the standard deviation, remember we need to calculate the variation of the critical activity. Variations of critical activities. Should get the A, C, F, H, I, K, L. Get the variation, get the total variation. Right, after you get the total variation, how to calculate the standard deviation, the square root of the total variation. Get the square root. Then you can make the answer. Okay, if you calculate, let me know the total variation. Anybody, did you complete the total variation? I got one answer is 0.777. Okay, get the square root. Let me know the standard deviation. That's also better to confirm this answer is correct or wrong. Now the student just calculate 0.88. Which one is correct? Only few activities, no? A, C, F, H, I, K, L. Should be one answer. Okay, another answer is 0.77. Think total variation now we can consider. Two students just mentioned 0.77. I just consider majority. I don't know is correct or wrong. Is another answer calculate. Yeah. 0.77. Then get the square root. You can find the standard deviation. Okay, standard deviation is 0.88. Okay, right. The standard deviation 0.88. Please confirm the answer. The 28 minus 24 divided by 0.88. Then simplify, let me know the value. Please let me know simplify value. Okay, we got it at 4.54 as a simplify value. Then you can use a set table and get the final probability value. The given table is not enough. You can download the table. Any questions, clarifications? Now you know how to apply the CPM method, critical path method. You know how to apply the PERT method. Now, sometimes the question not mention about, if you have a question, not mention this a PERT method, this a CPM method is depend on the given information. The information given for the activity durations, one column only. The CPM, if the given the 3 time estimate, you should know that PERT method example for questions. Likewise, you should have possible to identify. Right? You don't have any questions? Now I like to continue. Here you can see another example. I don't let to make the answer now. Exercise number 3, you can do yourself and try to get the answer. If you have any difficulties next time, you can ask a question. You need to compare answers with your friends and get the confidence. But however, if you have any difficulties, let me know. I will explain, right? Now I'm going to the questions. The benefit of the CPM and PERT. Using the both techniques, we have possibility to use take the some advantage useful at many stage of the project management. We can take the optimal decision. Mathematically simple given the critical path and the slack time. Still, I am not explained slack time. I'll explain later. Provide the project documentation. Useful monitoring cost. Not only that, we can identify the critical path. We can identify the non-critical activities. Critical activities. And also we can identify the entire project completion time. Likewise, there are so many the benefits. And not only that, we can find the probability value as well. Now we can go to the next step. We call that activity slack or float. You know that generally I mentioned that critical activities cannot delay because it's affect to the entire project completion time. And everybody, you know, non-critical activities we can delay some extent. Right? Exactly, we don't know how many days or weeks or month can delay the non-critical activities. Right? Therefore, we should identify how many days or month or weeks we can delay without affecting the entire project completion time. For that purpose, we can use the activity slack. It's very simple. We can calculate the slack. How to calculate the slack by the float. Earliest starting time, subtract latest completion time. This represents the excess amount of time available for that activity. We can delay the particular activity up to the amount of the slack time without affecting entire project completion time. When you're going to talk about the slack time or float, there are two types of slacks or float. We call the total slack and the free slack or free float or total float. The total slack is the number of days that activity can have before it starts, delaying the whole project. Or either we can say total slack means roughly how many days, month, or weeks we can delay. The free slack represent exactly number of days, month, weeks we can delay without affecting the entire project completion time. The free slack is the number of days that the activity can have before it start delaying the next activity, or either without delaying entire project completion time. We use two formulas to calculate total float and the free float. You know that if I'm going to explain the critical path, I asked to apply the latest early starting time, latest completion time method rather than the longest operating time, because when I'm going to calculate the total slack and the free slack, we can easy to make the answer using the total float and free float. Sorry, using the early starting time and latest completion time. Let's go to the first example. Very simple question. I'll explain with the answer available. If you don't have an answer, better draw the network diagram. Very simple example. Just try to find the critical path. Then after that, I'll explain how to get the answer. Here the network diagram. The green color line represents the critical path. Now you can see if you select any activity, you can see the head event and tail event. Activity A, tail event is 1, head event is 3. If you consider C, tail event is event number 3, head event is event number 5. Likewise, you can see any activity, tail event have a earliest start in time and latest completion time. Head event also have a early start in time and latest completion time. If you consider A, start in event, red color 0 we call earliest start in time I value. Normally we use the ij. The event number 3, 4, red color 4, we are going to say earliest start in time j value. Any activity in between that, in between any activity, you can see events. That event represent the earliest start in time I value, earliest start in time j value, latest completion time I value, latest completion time j value. According to the activity A, 12 is the latest completion time j value. The starting event, you can remember the I value. Finishing event, we call the j value. The LCJ is 4. Sorry. Early starting time j is 4. ETJ. Right. Early starting time I value is 0. Latest completion time j value 12. Latest completion time I value we call the 0. Likewise, any activity you can see a starting event, finishing event is represent the I and j. Early starting time I, latest completion time I, early starting time j, latest completion time j. Now we are going to calculate the total float. Here the critical path, completion time 25 months. We are going to calculate the total float, either free total slack. That's the formula we use. TFIJ means total float. IJ means in between the two event. LCJ, latest completion time J value. Subtract ESI, earliest starting time I value. Subtract DIJ, the duration of the particular activity. DIJ represents the duration of the particular activity. TF equal LCJ minus ESI minus DIJ. Right? Again, LC means latest completion time J value. ESI, earliest start in time I value. DIJ means particular activity duration. Let's go to the activity A. The DIJ value is 3. LCJ 12. ESI 1. Sorry, 0. 12 minus 0 minus 3. Answer should be 9. If you're going to calculate the C, 17 minus 4 minus 5. Answer should be 8. If you're going to calculate the B, LCJ4 minus 0 minus 4, answer is 0. If you're going to calculate the D, 10 minus 4 minus 0, 6, answer is 0. E, 17, the blue color 17 minus red color 10, minus 70. Likewise, you can see, I here calculate the C, activity C, answer is 8. Likewise, any activity you can calculate the total float. Then how to calculate the free float? The free float we are going to calculate using this formula FFIJ ESJ minus ESI minus DIJ. Earlier starting time J value, subtract earlier starting time I value, subtract DIJ, duration of the particular activity. ESJ, ESI, DIJ. Let's go to the diagram. If you consider A, earlier starting time J value is 4. Done. Under the third event, the red color 4. Subtract the EI, ESI. Early starting time value is 0. Then 4 minus 0 minus 3. Answer is 1. Activity A we can delay just 1 day because of the non-critical activity. If you're going to calculate the C, 17 minus 4 minus 5. Answer is 8. If you're going to calculate the D, 10 minus 4 minus 6. Answer 0. B, 4 minus 0 minus 4. Again 0. E, 17 minus 10 minus 7, 0. Then F, 25 minus 17 minus 8, 0. Why that we got the 0? All BD, EF critical path activity. Critical path is, we can't delay critical path. Now you can see the answer for the total free float. I explained earlier. Now you can see that the whole answer there is including ABCD all, duration DIJ, ESI, LC. We required the ESI, LCJ, ESJ. Then we calculate using the formula total float, free float, and also middle I just mentioned column the critical. The critical activities I put the critical. You can see critical activities, both total float and free float values are the 0. I put the years, these are the critical activities. You can observe both sides. Total float 0, free float also 0. Because critical path activity cannot delay. Then all the critical you can see 0. Right? You understood? Any questions? You understood up to that level? Let me yes or no. Not necessary make this type of table. If you know how to calculate one particular activity, total float, free float using the formula, just enough. Here I make the summary to get the idea about. You can go through again, see how we do the calculation. Please let me know you understood. Any questions, clarifications? Without wasting time, you can just mention. Then after that, we can stop the class, today class, then without break. No, then we can continue next time. Project crashing. Still, I'm waiting, get your feedback. You are not understood, I'll explain again. Still no answer. Okay, I got it now. Yeah, I got it. That answer is yes, clear. Right. Thank you, all of you. Then you don't have questions. I'll disturb the class now. Next time we can go to the project crashing. Right. Thank you, all of you, and good night.
Thank you, sir. Good night.
Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.